In this video, we are reviewing how to translate common functions. So here's the first one. Students in front of me are looking at this and they're deciding, is this going to resemble the parent function that its absolute value, that's quadratic, it's cubic, it's the square root, or it's linear? And this is linear. So below this really quickly, I'm going to write down ordered pairs that align with the parent function y equals x. -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. Raise your hand if you're in class if you can see which one I'm talking about over there. Hands up high. Got it. What do I do next? Okay. Well, the first thing I do is, remember, this is going to lie to me, and this tells me the truth. So I'm translating this. I'm going to shift this right now to the right one because it lies to me, and up 3 because it tells the truth. Right 1, up 3. And then I'm going to come back and cross them out. Any number that's directly in front of the parent function, and actually stuck with it, we're going to take that value and always multiply it by the y's, or the output value. So each of these is going to be multiplied by 2. So we have -4, -2, 0, 2, and 4. Now, how do I use these numbers in order to graph the line? Well, this is my 0, 0. So this says go to the right one because it's a positive x and go up 2 because it's a positive 5. Right 1, up 2. Right 2, up 4. From here, right 2, up 4. To the left 1 and down 2. Left 1, down 2, and left 4, down, left 2, down 4. And then I'm going to take my ruler and I will connect these. Now, as I went around and checked homework today, I gave a break to students who did just this, but no, I couldn't count that right on a test. I'm asking for you to graph the line, so you're going to take your ID out at that time when you do this for an actual test or assessment, and you're going to connect those lines. First thing I want you doing right now is I want you to identify this as a square root function. So I know that when I think of the ordered pairs for y equals the square root of x, I'm looking at 0, 0, 1, 1, 4, 2. Yes, 9, 3, but I will probably not graph that many points. How are they going to help me? When I look up here, I can see that inside there is a negative in front of the x. I need to factor that out. I'm going to do this a little bit slower. Negative times what gives us a negative x? X. Negative times what equals a positive 1? Negative x. And I always, because it's easy for me to make mistakes, I always distribute in my head. Okay, negative x, good, positive 1. Okay, I like this. This is what I'm going to graph. So, in this position, this is what I'm going to graph. In this position, it lies to me, so we have a shift to the right 1 and then up 3. Right 1, up 3, I go back and cross those out. Any value that is directly in front, not an nth root, but a value directly in front is going to be multiplied by the y's. 0 times 2 is 0. Times 2 times 2. And then this negative sign, or anything that's been factored out inside, will be multiplied by the input values, or the x values. So times a negative, and times a negative. This is showing your work for me. So here's my 0, 0. I'm going to go left 1 and up 2. Left 1, up 2. Left 4, up 4. 1, 2, 3, 4. 1, 2, 3, 4. And now I'm going to show you, by the way, the correct one, and then I'm going to show you what a lot of students do. Ready? That is correct. The arrow says it continues to go. So as it moves to the left, it continues to go up. Here is the mistake a lot of students make. They make all the nice dots, and then they do this. Why is that wrong? Why? Turn to your partner right now. You have 20 seconds. Why is this wrong? Remember, we have rules for domain, and you can see those rules right up there in the very top of the board. And there is a set rule. So if this was true, that says, hey, I could plug in 2 here, but look up here. If I plugged in 2 for x, -2 plus 1 would be -1. Can I take the square root of -1 and get a real number? No, that's why it stops right here. It's going to align to our domain. This would be my function. Why do students struggle with this? Because they're so eager to combine like terms. They say, well, can't I combine these? Doesn't this give me a -2? No, we're going to rewrite this. That's not allowed. We're going to rewrite this like this. So I'm going to put that -5 in back. Now, also recognize I need to factor out that negative sign. So it's looking like this. So when I graph this, what number is behind the x? There's nothing there. It's like a +0. So I'm not going to shift from the origin. I'm not going to go left or right, but I am going to drop down 5. 1, 2, 3, 4, and 5. I've taken care of this part. When I think about my square root, it is 0, 0, 1, 1, and 4, 2. Directly in front is a 3, so I'm going to multiply the outputs by 3. 0, 3, and 6. and my inputs or x's will be multiplied by a negative. Well, 0 times a negative is still 0 times a negative times a negative. So here's my 0, 0. I'm going to go left 1 and up 3. Left 1, up 3. Left 4, up 6. Left 4 and up 6. 2, 4, and 6. And that's my basic shape. All right, so here's our next example. We're looking at a parent function that's a cube root. So the first thing I'm going to do is I'm going to go, what is the cube root? So we have negative 2, negative 1, 0, 1, and 2, and negative 8, negative 1, 0, 1, and 8. Now, from here, I'm going to shift this opposite because it lies to me, and down 1. This is my point. I'm going to cross that out. There is no negative in front of the x, so I don't need to worry about that. This half is directly in front of the parent function, needs to be multiplied by the output value. So half of 8 is negative 4, negative 1/2, 0, 1/2, and 4. Okay, so here's my 0, 0. I'm going to go to the right one and up a half. Right 1, up half. Right 2, up 4. Right 2, and up 4. Left 1 and down a half. Left 1, down a half. And left 2, down 4. So I need to see you connect these. That's a must. You must connect them. Don't just leave the dots. Here's where I think students can make a common mistake here. I'm going to start by writing this on the end, so it looks like this. Okay, and it's a positive 2. Also recognize this is the same as a negative 1. And then inside I need to factor out that negative sign, so it's looking like this. So negative times what is negative x? Got it. Negative times what is a positive 1? I just want to make sure that I did that correctly. Everything looks good. And now I feel more confident in my ability to accurately graph this translated absolute value function. So absolute value is going to be negative 2, negative 1, 0, 1, and 2, and then it's going to be 2, 1, 0, 1, and 2. All right, so I've got all my numbers here. I'm going to move this to the right one and up 2. Right 1, up 2. There we are. Get rid of this. Right 1, up 2. That's looking great. What am I going to do next? This negative sign is going to be multiplied by the output, so it becomes a negative 2, negative 1. Well, 0 doesn't change. There's not a positive or negative. Negative and negative. Now, the inputs will be multiplied by this negative sign. A negative times a negative is a positive. A negative times a negative. So from here, this is my 0, 0. I'm going to go left 1, down 1. Left 2, down 2. Left 2, down 2. Right 1, down 1. And right 2, down 2. Make sure that you nicely. What I don't want to see is this. Please look at this. I'm going to erase this and just watch. If you found that point and it was right here and you went like this, I give you no points. Does everybody see how sloppy this is and I don't see your dots? Okay.